Hello everybody, and welcome back to Big Ideas. Today we're going to be talking about Lesson 4.2. Now, throughout all of Lesson 4, or Unit 4 I should say, there's one question that we always want to keep in mind. And that question is, what do we need in order to make a line? It's a question we kind of answered back in Unit 3. Let's see if we remember. In order to make a line, we need at least 2 points. Once you have 2 points, you can connect them and you can make a line. But there was also another thing that we could do. There was another way of making a line with just 1 point, but you needed something special to go with it. In addition to 1 point, if you know a slope, you'll be able to make a line, because by using the slope, you can find a second point. So as long as we have a point and a slope, we'll be able to make a line. 4.1 was all about what happened when the point and the line had to deal with slope-intercept form. If I gave you the y-intercept and I gave you the slope, we'd be able to write out an equation that looked like this. We would have y equaling mx plus b, where m is the slope, x and y are our variables just like normal, and b is our y-intercept. However, what happens if we don't have an intercept? What happens if we just have a different point? It makes it a little bit trickier. And we can't actually use slope-intercept form because there's nothing we can plug in for b. So what do? Well, we learn a new form of a line. Remember, all linear equations can be written like this, but it doesn't mean that's the only way linear equations can be written. The other way we're going to be learning today is called point-slope form, and here's how it looks. Point-slope form is y minus y1 equals m, and then parentheses x minus x1. Now that's a lot of variables to deal with. Slope-intercept form only had 4 variables, this one has 5. That being said, a lot of this is stuff that we kind of already know. Let me tell you what I mean. In slope-intercept form, we also had a y, an m, and an x. These 3 things are going to stay the exact same. Your y is just going to stick around. You're never going to have to change this to be anything else because your equation should be y ends up equaling some other side. y1 is where things get a little bit different. y1 is going to be the y value of any point that we are given. So as long as you have a point and you have a slope, you can use point-slope form. This is the y value of that point. What we're doing here is we're finding the distance between the y value that we're trying to look at and an original y value to help us figure out the equation. M, as always, is just going to be our slope. That's never going to change. X, just like in slope-intercept form, is just going to stick around. Remember how in slope-intercept form, we never really changed the x or the y, we only changed the m and the b? It's the same thing here. However, this x1 is going to be the x value of our point. Just like in 4.1, our goal for today is going to be to learn how to use this by plugging things into it, then learn how to do it with a graph, then learn how to do it when we're just given a couple of points. So let's try something down here in the notes section. I'm thinking of a line. The slope of this line is 3. And we're given a point that's on the line. I'm telling you this line crosses through the point -8, 3. And we need to figure out how to put this into point-slope form. The first step that I'm always going to recommend is just writing down your point-slope form. So we have y minus y1 equals m times the quantity x minus x1. Now, again, your y and x are just going to stick around. You're never going to change those from being y and x. But do we know what m is here, given this information? Well, yes. M is going to be our slope. So, we're going to rewrite this. Y is always going to stick around. We're going to have minus some value of y1. I'm just going to leave a blank space for now while we can fill that in. Our slope is 3. So let's put 3 in where m should be, because slope is represented by the letter m. We don't yet know what our x1 is, but we do know that x is going to be sticking around, because x and y are never going to change. They're always just going to stick around. All right, good first step. At this point, we now need to figure out what y1 and x1 are. y1 is the y value of our point. Well, in a point, x is always the first number, and y is always the second number. So, this number here, this little 3, is y1, and this negative 8 has to be x1. All we do is we just take those and plug them into the equation. y1 is supposed to go right here, so let's put our 3 there. x1 is supposed to go here, so let's put our negative 8 there. I'm putting in parentheses since we don't usually like to have a minus a negative, or a plus a negative. It makes it a little bit weird to have both signs next to each other. So this is it. This is point slope form. But there is still one thing that we need to do, because big ideas will tell you that this is incorrect if you put it in. We need to see if there's any simplification we can do. Well, y minus 3 can't be simplified, so let's keep that as it is. 3 parentheses x minus negative 8. Is there anything that can be simplified in here? Well, yes. Minus a negative is just the same as plus. So we rewrite it as 3 times x plus 8 instead of minus negative 8. And we're done. That is point slope form. Let's try out some of the problems on the next page, page 104. So if I go over to page 104, you'll see that there are 6 problems at the top. I don't want you to have to do all 6. I just want you to try out the first 3 of them. So once again, on page 104, right up here, I want you to try these 3 problems. Pause the video, try them out for yourself, and see if you can get these into point slope form. Pause the video, and we'll come back in just a moment. All right. Hopefully at this point you've had a chance to pause the video and try these out. These are our answers. For problem number 1, we should have gotten y minus 1 equals negative 3 times the quantity x plus 2. We ended up with that double negative thing again over here, so we simplified it to plus. Right over here, we should have ended up with y minus 5 equals 2 times x minus 3. Again, because we plug in 2 for our slope. 5 is our y1, and 3 is our x1. For number 3, things got a little bit weird because we have y plus 2 over here, but negative 1 times the parentheses, we can just rewrite that as negative parentheses. To simplify, we sometimes have to get rid of redundancies, numbers that we don't really need to still have the same meaning. For instance, I could tell you that 3 plus 0 plus 0 plus 0 plus 0 plus 1 is 4, but those zeros are redundant. They don't tell us anything new. I could just say 3 plus 1 is 4. It's the same thing here. Instead of saying negative 1 times the parentheses, we can just say negative times the parentheses, because anything times 1 is itself. All right, let's move down to some of these problems down below, and I specifically want to take a look at a problem like problem number 11. Let me zoom in real quick. Give me just one moment to fiddle with the paper here. For a problem like problem number 11, we run into a little bit of an issue. First off, we're not given the slope and a point straight off the bat. We need to figure both of those out, and that by itself can be a little bit tricky. But there's something even more dire going on here. They're asking for slope-intercept form, not point-slope form. You know, y equals mx plus b, the stuff we did last section? Yeah, they're asking for that, but they don't actually have a y-intercept they're giving us. True, some of us might be able to predict what the y-intercept is, but unless they list it off as being through that point, we don't actually know if it goes through that point. So we can't use slope-intercept form to find an answer here. As strange as it sounds, when you don't have a y-intercept and you're asked to put something in slope-intercept form, our goal is going to change. We instead want to put this in point-slope form first, then convert it into slope-intercept form. What do I mean by that? Well, we want to put it into y minus whatever y1 is equals whatever m is times x minus whatever x1 is. We want to put it in that form first. Then we're going to change it into slope-intercept form. So first things first, can we figure out the slope from this diagram? The answer is yes, we can. Anytime we have a graph, we can figure out the slope. That being said, the way that we would do it with a graph by counting is a little bit weird because our dots are kind of at halfway points. I wouldn't recommend counting for this one. So what can we do instead? What's that surefire method to always find the slope? Well, the slope is always just going to be our rise divided by our run, correct? So if we're looking for a rise over run, the rise is just the change in the y value as we go from here to here. We can always write the change in the value as one of the y's minus the other one. And the change of x is the same way. y2 minus y1 over x2 minus x1 is our slope formula. What we really need to do is we need to label these x2, y2, x1, and y1. So, step one, let's pick a point to be point number 1 and point number 2. I'm going to call this one up here point number 1, and this one down here point number 2, but it really doesn't matter which one is which. All right, good enough. At this point, let's see what we can do. What's the x value of point number 2? What's the y value of point number 2? Well, the y value of point number 2 is the second number in point number 2. That's negative 9. So y2 is negative 9. What's y1, the y value of point number 1? Well, it's the second number of point number 1, which is negative 3. So that there is going to be negative 3. We have negative 3. What's the x value of point number 2? It's the first number in point number 2, so it's negative 1. And finally, what's x1? Just 1. So we have a problem to solve here. We got to do negative 9 minus negative 3, and negative 1 minus 1. A lot of negatives and minuses here. Negative 9 minus negative 3 is the same as negative 9 plus 3. So it's negative 6. Negative 1 minus 1 is negative 2. So our slope is negative 6 over negative 2, which we know can simplify down to just be 3. So we've got our slope. Our slope is 3. What about this x1 and y1 business? We just need a point, right? Well, it turns out, because we're given 2 points here, we can use either one of them in our point-slope form. Let's just use the top one, point number 1, for instance. x1 would be 1, so we're going to put a 1 here. y1 would be negative 3, so we write negative 3. All we have to do now is simplify this. So I'm going to do this on a separate sheet of paper. Y minus negative 3 is just the same as y plus 3. And that's, of course, going to equal 3 times x minus 1. And if we were asked to put this in point-slope form, we would just be straight up done. This would be the answer. But we were asked to put it in slope-intercept form, which presents a little bit more of a problem. We have to figure out a way of putting this into point-slope form. So what can we do? Or sorry, to put it in slope-intercept form. Well, as a reminder, we're trying to turn it into a form that looks like this. Y equals mx plus b. Well, it looks like in this bottom form here, not too much is different. First things first, though, y is going to end up being all by itself, and there's going to be no parentheses. So our goal will be to get rid of both of those things. How do we get rid of a plus 3 if it's attached to our y? Well, to get rid of plus 3, let's minus 3 from both sides. Minus 3 and minus 3. That'll give us y equals 3 times x minus 1 minus 3. A little bit of a reminder from middle school, you cannot do anything to something that's in parentheses on the other side. If you're subtracting 3, you're subtracting 3 from this side, not from what's in parentheses. Parentheses act like a box. You can't take anything out or put anything in unless you get rid of the parentheses. Okay, this looks pretty similar to slope-intercept form so far. But we got to get rid of these parentheses. How do we do that? Does anybody remember how to get rid of parentheses? We have to use a little bit of a property called the distributive property. We want to distribute. That means multiplying everything in the parentheses by this outside number. So 3 times x is 3x. 3 times negative 1 is negative 3. And we have our minus 3 out here still. We're super close now. The only difference is we have 2 numbers here instead of 1. But this is an easy fix because we can combine these two. Y equals 3x minus 6. There is one more problem type you'll see, and it's going to be on page 105. On page 105, we put a couple of points, but they're not written as points. They're written in function notation. Let's take a look at problem number 14. We want to, it says, write a linear function f with the given values. A linear function is just the same way, it's a different way of saying write a linear equation. We're just going to use function notation for our final answer. But we're going to solve it the same way we solve any other problem in this. First things first, let's put these and change them into points. As a reminder, if you didn't watch the 4.1 video, to turn these into points, your input, or x, is always the thing in parentheses. So negative 2 will be first. Whatever it equals will be your y. So that equals 1. Over here, our input in parentheses is 1, so that's our x value. Our output is 7. That's our y value. We need to figure out a point and a slope in order to put this into point-slope form. Well, let's start off with the slope. We know that we'll have to use our slope formula, y2 minus y1 over x2 minus x1. y2 minus y1, x2 minus x1. So what can we do here? Well, let's label one of these points to be point number 1, and let's label the other one to be point number 2. I'll say that this one here is point number 1, this one over here is point number 2, just for simplicity's sake. That means that y2, the y value of point number 2, is 7. Oops. y1, the y value point number 1, is 1. It's the second number. That's what y always is, the second number. x2 is just the x value of point number 2. Here's point number 2. There's our x. It's 1. And the x value of point number 1 is negative 2. 7 minus 1 will give us 6. 1 minus negative 2 is the same as 1 plus 2, giving us 3. So our slope is 2. By combining the fact that our slope is 2 with a point of our choice, I'm going to choose 1 comma 7, because that one seems like a cool point to use. We can write out our point slope form, which is y minus the y value of the point, 7, equals our slope, 2, times x minus the x value of our point, 1. But we're not done yet, because again, we want to write it as a linear function, meaning we want to get it into slope-intercept form, then just change our y format into an f of x. So we're going to add 7 to both sides to start to get y by itself. That gives us y equals 2x minus 1 plus 7. Next up, we need to distribute. That gives us y equals 2x minus 2 plus 7. Oops, I realized y'all couldn't see that. And finally, we combine this negative 2 and this plus 7, giving us our final answer, y equals 2x plus 5. To change this into a linear function, remember that y is the same thing as f of x. So all we need to do here at the end is just change our answer to be f of x equals 2x plus 5. And we're done. All right, thank you so much, everybody. Have a fantastic rest of the day, and I'll see you next time.